So now we're on chapter 12, linear regression and correlation. It sounds like a lot of new things, which there are some new concepts, but we're going to also see that we are just continuing on in inferential statistics. So part one, what we're going to cover this part of the week is these first three sections. So we're going to do a little overview of linear equations and then look at scatter plots, which are just graphs that plot different points that are based on two values, two separate variables, values from two separate variables. And then we'll look at what we mean by the regression equation, which is just a linear equation, equation of a line. And then next time, part two of this chapter, we will look at hypothesis testing for correlation and then doing some prediction with our regression lines. So let's start off with this first section where we are just going to review a little bit about linear equations. So if we want to put this in the context of inferential statistics, which is what we've been doing for these last several weeks, we're making inferences about a population mean and proportions. But if we think about just the times when we've done confidence intervals for a population mean or hypothesis testing about a population mean, we always thought of mu, this unknown but fixed value mu. It's a single value, one single value that we're trying to estimate with x bar. Now sometimes we know that that value, that population mean, is not a fixed value, but it varies with respect to some other variable. So as some other variable changes, we expect that sort of what we want to estimate is also going to change. So another way to put that is sometimes the population mean to be estimated is known to be variable and dependent on some other variable, which we call that other variable the independent variable. And we can write down the relationship between those two things as a linear equation, right? Where y is the dependent variable and x is the independent variable. And then we can write down that a relationship between x and y as y equals some constant a plus some constant b times whatever x is. All right, so you recognize that as the linear equation. Now it's written a little bit differently than what you encounter in your algebra class, where we might typically see it as y equals mx plus b. All right, so we kind of want to set that aside and sort of rewrite it as y equals a, where it's that some constant number plus some value b times the independent variable x, and that's equal to y. All right, so a in this scenario is what we call the y-intercept of the line. So it is where the line crosses the y-axis. Oops, spelled line. There we go. Line crosses the y-axis at the point 0, a. And then b, the number that's multiplied by x, is what we call the slope of the line. All right, and remember what the slope of the line is. Slope is the change in the dependent variable, or y, over the change in the independent variable x. And if we look at these two values, x is the independent or a predictor variable, and that gets measured along the horizontal axis. And the y, the dependent or response variable, is on the vertical axis. Okay, so we've got xy axes here. If we want to look at a equation, let's say y equals -2 plus 1/2 x. So if we plot or graph that line, so that -2 tells us where the line is going to cross the y-axis. So we're going to have a point where x is 0 and y is -2, so that's right there. And then actually the slope tells us how to find another point. All right, the 1, that +1, tells us what the change in y is. So that +1 tells us to go up 1. All right, so we go up 1, and then the 2 tells us to go right 2. That's the change in x. So if we go up 1 to the right 2, we get a point at -2, -1. And then we can do that again to get another point. All right, the 1 tells us to go up 1, the 2 tells us to go to the right 2, and we can get another point. And that's enough to be able to graph that linear equation. All right, so the -2, that matches up with that value, and then the change in y over the change in x, that matches up with the slope or the number that comes in front of that x. Okay, so here's an example. The mean roller coaster speed of the top roller coasters in the US is a variable, all right? It changes, and one of the things that relates to that speed is the height of the roller coaster. So there is a relationship between height and speed, and it's actually can be given to us as, actually it's written down here, that the mean speed is equal to 51 miles per hour plus 0.15 times whatever the height of the roller coaster is. So we want to pick out what the y-intercept, or A, is in this example. That's going to be the 51 miles per hour. And the slope is the 0.15. Okay, and we can think of that as miles per hour per feet of height. So 51 is just miles per hour, and the slope is in terms of whatever the units are on the y over the units on the x. Okay, so the independent variable, if we go back, that is the height. All right, that's what we're considering x to be. And the dependent variable then is the speed. All right, that's what y is measuring. Okay, so if we go now down to looking at A is what y equals when. All right, so if we think about what happens when x is equal to 0, so that is, all right, where the line crosses the x-axis, and that's when x is equal to 0. All right, so that tells us that 51 miles per hour is the speed that the roller coaster reaches when the height is equal to 0. All right, now B, that's the number that we're multiplying by x, the slope, is the amount that speed, okay, because that's the y value, y changes for 1 unit change in height. All right, the x value, all right, because we have got the change in y, or in this case speed, over the change in x, which is height. All right, so in this case we have 0.15 is the amount that speed changes for a 1 foot change in height. All right, so once we have this equation, which we'll talk about how we get the equation, how we get the A and we get the B, but once we have it, we can use it to predict what a mean value is, or a mean speed is. So if we have a 30-foot high roller coaster, that means we've got x equal to 300. I'm sorry, not 30, but 300. So to get the speed, we're going to replace x with that 300. So we get y equals 51 plus 0.15 times 300, which we plug that in, we're going to get 96 miles per hour. Okay, if we choose a different value for height, okay, we get y equals 51 plus 0.15 times 175, and that gives us a height of 59.75 miles per hour. All right, so the thing to remember is that these values that we just calculated, all right, those are mean speeds. And you can see that they're varying based on what the height of the roller coaster is. Okay, so for all roller coasters of 300 feet, the mean speed is predicted to be 96 miles per hour. Or of all the roller coasters of 175 feet high, the mean speed is predicted to be 59.7 miles per hour. Okay, and that's what we highlight here with this note, that y is the mean speed. The actual speeds for a 300-foot high and a 170-foot high roller coasters will vary around those mean speeds that we were able to calculate. Okay, so let's look at another example. The mean speed of cars on the freeway varies with the number of patrol cars deployed on the freeway. So let's determine what these following things are. So in this case, what is the independent variable? All right, what is the thing that's going to cause basically the other variable to change? Well, the independent variable is the number of patrol cars. And what depends on that is the speed, the average speed or mean speed of cars. So if the mean speed is 85 when there are 0 patrol cars and the speed decreases 5 miles per hour for an increase of 1 patrol car, what are these following things? The y-intercept. Okay, well, we have that when there are 0 patrol cars, so that means that x equals 0. The mean speed is 85. Well, that gives us exactly what the y-intercept is. So the y-intercept in this case is 85. And then the speed decreases 5 miles per hour for an increase of 1 patrol car. So that tells us that the change in our dependent variable, the change in y, the change in the mean speed is -5. It decreases. And we could think about putting that over 1. So it goes down 5 miles per hour for every 1 patrol car that is added to that section of freeway. All right, so we can write down what the equation is here. It's y equals, all right, remember that the y-intercept is a and the slope is b. So y equals a, which is in this case is 85, and plus b, in this case is -5x. Or we could just write that as y equals 85 minus 5x.